Hello. In this question, it is asked two identical conducting spheres are charged to plus 2q and minus 2q. As you can see, this is plus 2q and this is minus 2q. Okay. And are separated by distance d. So the distance between these two charges, as you can see, it is d. Okay. Which is much greater than the radii of the sphere. So we can actually, since this is much greater when compared to the radii, that means we can ignore the this length length of radii. Okay. The magnitude of force of attraction on the left sphere is F1. The magnitude of the force on left sphere is F1. It is given. Initially, it is F1. After two spheres are made to touch and then are represented by distance d, re-separated by distance d, the magnitude of the force on the left sphere is F2. So once these two balls are touched, and again re-separated or brought back to this position again, now the force on this object or this charge is F2. Initially it is F1. F1, finally after touching it is F2. Which of the following relations is correct? Okay. Now we have to find out the electrostatic force F1 initially, then we have to find out the final force after touching F2, then we can compare them. So F1 will be K into plus 2Q into minus Q, because the electrostatic force is acting between these two objects, right? So that is why we have to consider these two charges divided by the separation square. Separation is d square. Okay. So what do we get? Minus 2kq square by d square. Okay. So F1 is this much. Now once they are touched, they will share some charge. Once they are touched, they will share some charge in this process. So after that, they will have different charges. Now we have to find out what is the charge they are having. First, we have to find out net charge. Q net is plus 2q minus q, that is q plus q. Okay. After they are touched, this they will be having charge. They will share the charge, right? So they will be having charge. Let us charge is equal to average of the net charge, q net by 2. So q net is plus q by 2. That means now they are having plus q by 2 charge on each end, and they are again re-separated by distance d. Now in this case, F2 is the force acting on this electrostatic force, and we can find it out. K is equal to plus 2q, plus q by 2 into plus q by 2 divided by d square. Okay. So 1 by 4 k q square by d square. Okay. Now we can do one thing. We can multiply 2 here and divide by 2, right? That means it will remain same. This 2 gets cancelled and will be remaining with 1 by 4 kq square by d square. So that won't harm this. So we can write 1 by 8 2kq square divided by d square. Okay. Now let us look at the magnitude. The magnitude of F1, which is 2kq square by d square. Let us ignore this symbol for now. Let us only focus on the magnitude. So the magnitude is 2kq square by d square. Okay. Can we replace this 2kq square by d square as F1? Yes, obviously 1 by 8 F1. F2 is 1 by 8 F1. So finally what we can write, F1 is equal to 8F2. And as we can see, this is the relation between initial force and final electrostatic force. As you can see, option number E is the correct answer. Thank you.